Now, looking at these two equations, can we tell the function family that we are dealing with? Let's start with the first equation. Is it an exponential? Is it a hyperbolic? Is it a parabolic? Or is it a cubic function? Well, we see that x is in the denominator, and therefore this should be a hyperbolic function. Now, what features do we find in a hyperbolic function? We say the hyperbolic function has asymptotes. Now, let's go ahead and find the asymptotes. We say to find the vertical asymptotes in a hyperbolic function, we equate the denominator to 0. And the denominator in this equation is x minus 2. So, let's go ahead and equate that to 0. We have x minus 2 is equal to 0. Now, let's solve for x. We get that x is equal to 2. Now, we need to show that in a graph. Let's draw a Cartesian plane with the x and the y-axis. In the x-axis, we need to find the point where x is equal to 2. This is 1, this is 2, this is 3. Minus 1, minus 2, minus 3. 1, 2, and 3. Minus 1, minus 2, minus 3. Now, where do we find x is equal to 2? There is x is equal to 2. Now, through that point, we will draw a vertical line. This is x is equal to 2. Now, let's find the horizontal asymptote. To find the horizontal asymptote, we said we take whatever value of q there is over there and equate it to y. So we get y is equal to 1. Therefore, our horizontal asymptote is equal to y is equal to 1. So we draw a line through the point y is equal to 1. Now, we are done with the vertical and the horizontal asymptotes. Now, what we need to do to complete the graph, we need to find the intercepts, which is the x and the y intercepts. Let's go ahead and do that. Now, as we know, to find the intercept, either the x or the y-intercept, we need to equate one of them to 0. Let's start with the x-intercept. So to find the x-intercept, we let y equal to 0. So when y is equal to 0, we get 3 over x minus 2 plus 1. Transpose 1 to the other side, we get x minus 2. We cross multiply, we get negative x plus 2 is equal to 3. Now we solve for x. Negative x is equal to positive 1. Therefore, x is equal to negative 1. So we go ahead and note that over there. Now let's find the y-intercept. Now to find the y-intercept, we need to equate x equal to 0. Let x equal to 0. And after we do that, we get y is equal to 3 over 0 minus 2 plus 1. And therefore, we have y is equal to negative 3 over 2 plus 1. And this solves to negative 1/2. Therefore, we'd have something over there. Now, what does this mean? This means we'll have our one portion of the graph going through that. Now, the other portion of the graph will not have either the x or the y-intercept. It will just be the same graph on this other side of the asymptotes. And you are done. You have successfully drawn your graph. Now, looking at the second equation, we see that we have h of x is equal to 2 to the power x. Now, this tells us something. What function family are we dealing with? Is it a parabolic, exponential, hyperbolic, or is it a cubic function? Well, x is an exponent, therefore it must be an exponential graph or an exponential function. Therefore, what do we find? What features do we find in an exponential function? Yes, we find the horizontal asymptote. Now, let's go ahead and find the horizontal asymptote in this case. So, in this case, we know that the horizontal asymptote is given by y is equal to q. But when we look at this function, we see that q is actually equal to 0 because there is no number or any value over there. Therefore, we have our horizontal asymptote as y is equal to 0. So we go ahead and show that in a graph. we know that the x-axis is exactly the line y is equal to 0. And therefore, there is no need for us to draw a dotted line. So what this means is that our graph is not going to touch the x-axis. Now, next up, we need to find the x and the y-intercept. How can we do that? We know that to find the x and the y-intercept, we let either of them equal to 0. So let's start with the y-intercept. Let's let x equal to 0. So we would get y is equal to 2 to the power of 0. And we get that y is equal to 1. Therefore, we note it over there. As usual, we need to find our x-intercept. What do we know about the x-intercept? We know that to find the x-intercept, we need to let y equal to 0. But what do we know about the value y when y is equal to 0? We know that the line y is equal to 0, we said it was our asymptote from the equation. In general, we know that the asymptote is the line that the graph cannot touch. So what does this mean? This means there is no x-intercept. All right. Now that we have all that information, let's go ahead and try to draw our graph. How do we then draw our graph in this case? We need to know in which direction is our graph going. So in order to do that, take two extreme numbers, x is equal to 4 and x is equal to -4. And after plugging these two in, I should have an idea of where my graph is going. Now, let's take 4. Y is equal to 2 to the power of 4. What do I get? I get y is equal to 16. This means there's some point over here, x is equal to 4 and y is equal to 16. And then let's plug in x is equal to -4. What do we get? Get y is equal to 2 to the power -4. And what is that? That's going to be y is equal to 1 over 16. Now, where is this point? This is some point over here where x is equal to -4 and y is 1 over 16. So what does this tell me? This tells me that my graph looks something like this. So in the next video, we are going to look at the mixed graphs and try to apply this information in solving an exam question. All right.